Good evening, everyone. My name is Vivek Upman, and I represent Seagate Technology. And I'm sure you guys must have heard about Seagate, our businesses globally, and the focus that we have in India. So I would like to thank the organization here and the dignitaries who are presented here to give us this opportunity to explain our stand, basically the technologies that are being used by Seagate to drive the various innovation, machine learning or automation that we talk about. So I'll take this time given to basically impress upon you guys, or to extol that what are the building blocks of the technology that Seagate has been using all over the years. And incidentally, this is the 40th year in progress of our inception. So we've been manufacturing hard drives for 40 years now, and it's a long time to talk about what we have been doing. So I have a short video which will help you understand the Seagate's journey. It's a very beautiful video and will give you great insight into what we have been doing. Yeah, so that was our journey of 40 years. As you can see, it started off from a very small diskette to something as huge as a 16 TB hard drive that we have recently launched. And if you could see, a lot of terms that we have been using, you could see right in the video, drone or a smart manufacturing being shown there. So what we are trying to understand here is that how the technology has advanced with the the changing nature of the demands of the industry, and how as a technology innovator, Seagate has been able to keep terms with it and help organizations to address those needs. So let me just give you another snapshot of. So we've already seen what Seagate is. It's a 40-year-old company and has been an innovation giant. And with the video already done, I would just like to focus your attention that not many of you would know that Seagate currently houses something like 700 people in India. And they are all the R&D brains. So the global R&D support center of India is right here in India, in Pune, for the world, sorry. So that is a kind of focus that Seagate globally has on Indian infrastructure or Indian brains or Indian technology to help go further. So in tune with whatever the India has to offer, this becomes the center of the technological hub, the innovation, the automation, machine learning, whatever you may call about. So this is what Seagate has been globally and for India. Now, many speakers have spoken about those big terms, and that we are in the middle of a technological shift, kind of a disruption. So as you can see, those 40 years, Seagate has done something like a kind of a data mapping for last 40 years, ever since the computers started to take shape. So if you look at this slide, this basically talks about kind of a 4 genres. So right now we are at something called IT 4.0, which is basically stepping into the zone of 5G, fifth generation. And that is going to change fundamentally how we look at things, how the data moves across, and not just humans communicating and releasing data. It will be the data creating the data. So going back, let's look at 1.0. You remember, those times where mainframe computers first got out? So that was the time when humans realized that there is some kind of potential in the data. But it was only about translation using a software, but nothing more. We just realized that there is something more to it than what we have been doing. Then came 2.0, which was more about, remember the client server model, the PC started proliferating everywhere. And now we realize more and more, but at the same time, every data was stored locally. The harnessing, everything was locally. It was more about keeping all your data digitized with you. That is where 3.0 came in, when we realized that there is something called cloud. There is cloud computing, there is infrastructure as a service. I don't need to keep my data in-house. I can keep it on the cloud. That is where the 3.0 started to came. And we started differentiating between different kind of applications or data. Something I'll keep on the cloud, something I'll keep it on-premise, so on and so forth. But still, there was more to be left here were we really harnessing the data in this age as we speak? This is data 3.0, where we always speak about how much data I have which is actionable. I have, let's say, a terabyte of data of last 10 years. How much I can utilize to, let's say, forecast in a way that I can launch much more intelligent products or reach out more than I would want. So that is the harness of the data has still not been realized. That is where IT 4.0 is going to come in. The reason because we are still kind of lacked with respect to the bandwidth in terms of the speed that they have and also the data processing. Right now, the data still processes at the core, which we call it. So you have something called as an endpoint where the data is generated or activated. My handset, tabs, computers, my smart cars, if at all. Then every data is pushed to the cores or the data center. There it gets processed and then brought back for actionable intelligence. Now that is where the lag has been with data I 3.0, and that's where the 5G will make hell of a difference. So difference between 4G and a 5G is in terms of the faster speed and that the data processing is locally within the source. Once that happens, that is the data faster at a faster speed, because there will be a lot of micro modular data centers spread across a particular region. So it is a shorter distance than the 4G. 4G, the distance travel longer. In 5G, the distance will travel shorter but at a faster rate. That's where you'll also have something which you call as edge computing. All the data that is generated, so you can look at the slide, you'll see a lot of drones there, there is smart car, there's smart manufacturing. So they will keep generating the data, and the micro modular data center, which is nearby to the location, will process it and send back for action. So a classic example could be, let's say we have been talking about Tesla cars, right? Autonomous vehicles. Now it is not just the Google map or the map GPS positioning that they require for their execution. They need exact data of, the complete awareness of the vehicles or the traffics around them, and to take intelligent machine learning decision. So for that, you need the processing to be locally available. So it will be constantly emitting data. The amount of speed it is driving, when to, what are the traffic right in front, at what time they need to press the brakes. This is just one of the examples. Another, examples could be something from your home. So let's say you have an RO purifier or a washing machine, and it has to go for a service, let's say once in 6 months, which we usually forget. So we can have a smart add-on devices where automatically it relays message to the nearby service center, and the appointment could be set. So this is also a part of an automation or a machine learning or an innovation which could be added. Now this is something which will be done in the near future very soon. It is not something that we are talking about something 5 years, 10 years from. Once 5G is activated, all the devices in your home will become smart and to their true potential, which we only see in the matter of Alexa or the Google Chrome devices. It will go much beyond that. So this is what IT 4.0 is all about. And so let me look at other slide. Wait, I think there's some problem with. Can you call someone? I think the screen is working here. I'm really sorry for the brain. So yes, this was what I was talking about, the endpoints and the core. Currently, we are stuck at that. And once the 5G comes in, the edge infrastructure comes into play. And that's where all the potential of the data in terms of innovation, machine learning will start come into picture. So let's look at a very important graph which will capture some of your interest is that now Seagate in partnership with IDC has created a kind of a analysis study to understand how much data is going to be created in the next, let's say 10 years from now. So what you see on the screen is the data age report of the entire data in this universe that will, whether from consumer or from the enterprises, that will be created over the next many years. So as you can see, the annual size of the data sphere, which you guys are going to create as part of it, is going to be 175 zettabytes. So that is the amount of data that will be created. Now currently, if we see, we are creating something like 33 zettabytes. Now to give you an idea about what a zettabyte typically means is, it is like a billion terabytes or many, many more terabytes. So what I'm trying to say here is that the amount of data that will be thrown out in the next 5 to 10 years will be humongous, much more than you can imagine. And for that, you need innovation at every component, at every solution to make sure that the entire solution can be justified for the future needs. So with that, I'll just give you a snap of what kind of products and solution that we have currently, which will actually aid in taking care of these intricate problems. Because if you understand that 175 zettabytes of data will be created, eventually that will be held on a hard disk, the so-called dumb device. But that is where the entire data will be captured. So I would just want to educate upon few of the technologies that Seagate has been doing for the last 12 to 15 years. What you see is on the left side, HAMR is one of our kind of a benchmark technology which allows to increase the areal density of the hard drive. So if you guys just recall, what the hard drives look like and what are the challenges that we are facing right now. So we just spoke about 175 zettabytes required. So the challenge for every CIO currently is, that the increasing amount of data that is there, and they would always want the data to continue to increase, but the cost of increasing the data remains less. So that means we have to go down to the component level to make sure that the same hard drive is able to populate more and more areal density or more and more data. We have been doing that. We've been doing that 1 TB, so now we are to 16 TB, but that's where it ends. Because if you look at the building blocks of a hard drive, it has disks where all the data is captured in a data bits. Whenever you do read and writing, everything is captured on the disk by a read-write arm, which is called an actuator arm. Now, going by the continuous stacking of the drives, we cannot increase the form factor of the drives, and this is where the innovation started to die. That can we stack more and more areal density in this hard disk, which has reached something like a 16 terabyte. Now, this is where a technology called HAMR, heat-assisted magnetic recording, has come into play, which allows us to increase the areal density of every single data bit. So what it does is, if you just imagine a disk which a lot of data bits in that, what we do is that we heat every single data bit, make it smaller and smaller, and stack more areal density. Thus, we keep increasing the capacity of a hard drive. That's how you keep getting, a higher capacity drive, which had reached its limit till 16 terabyte. So this is the hard drive that we have just successfully tested. It's a 16 TB drive with the technology. And There are few more technology, differentiations that I would like to have spoken more about, but I guess I've been given a label that the time is out, so I would like to cut it short. There is a technology called multi-actuator 2, which basically we have spoken about, the increase in capacity. But with increase in capacity, can I increase the performance also? So this multi-actuator, what it does is, it divides the actuator arm into two, and one takes care of read, another takes care of write, increasing the performance. So what we are trying to say is that with this innovation, we are not only allowing to increase the capacity of a hard drive from 16 TB to 40 TB maybe in the future, we are also doubling the throughput, which is a major concern of any CIO. Now, there are a few other things which maybe we can connect, after some time if anyone would want to have an interest on that. This is a nitro Durarite technology for Seagate Enterprise SSDs. I like to skip that. These are some of the products which you guys have already known about. Exos is our Enterprise HDD, and Nitro is our Enterprise SSD, which is out in the market. One last work, which is very important, particularly from the solution perspective, because there are many distinguished CIOs here. Now, Seagate has been known as a component manufacturer. And over the last 3 to 4 years, we have done a lot of changes. One was getting into flash. Another was becoming a solution provider in storage systems. So there was this company called .Hill Systems, and we acquired that 3 years back. It is now completely internalized, and we call it as Seagate Systems. So now Seagate has the entire array of storage systems, right from an all-flash array, hybrid flash array of 2U24 to an ultra-dense storage of something like 4U106, which can cap up till like 1.7 petabytes of storage in a single box. So these are the new things that I thought, I could just, talk about, that Seagate is now not just a component manufacturer, but also into a whole storage systems. So thanks a lot for being so nice audience.